Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the June 2024 International A-Level Edexcel. This is the International A-Level Edexcel Pure Mathematics P3 paper. And here we have a question which part A is dealing with basically this graph which shows the path of a golf ball after the ball has been hit until it first hits the ground. So it's been hit at this point over here, and this point shows where it hits the ground. The vertical height, h meters of the ball above the ground, has been plotted against the horizontal distance x meters measured from where the ball was hit. So this is basically the vertical displacement from the place where it was hit, and this is the horizontal displacement from the place where it was hit. The ball travels a horizontal distance of d meters before it first hits the ground. So it's on the ground, it's hit, then it hits the ground again, right? So the ball is modeled as a particle traveling in a vertical plane above horizontal ground, and the path of the ball is modeled by this equation: h equals 1.5x minus 0.5x times e to the power of 0.02x, and the domain of this function is x is between 0 and d. So we're only considering this from when it's hit to when it hits the ground a second time. So use the model to answer parts A, B, and C. Find the value of d, giving your answer to 2 decimal places. And it said solutions relying entirely on calculating technology are not acceptable. All right, so now it's horizontal ground. So the place or the places where it is going to be on the horizontal ground is when h is equal to 0. And we can see that there's going to be 2 places, when x equals 0 and when x equals d. Okay, we can see that from the graph, right? So what we're going to do is we're going to say, okay, when h equals 0, we're going to find what x is. We'll probably find 2 values of x. One of them will be when it was hit, one of them will be when it hits the ground, and that would be our d value. So when we put h equals 0, we got 1.5 x minus 0.5 x times e to the power of 0.02x, and that's equal to 0. So we're going to find when its displacement is 0 when it's on the ground. So we can see here straight away that there's a common factor of x. Okay, and then I can take out that common factor, and I have a product of 2 factors here. So I have 1.5 minus 0.5 e to the power of 0.02x equals 0. So x equals 0, okay, that's like one value of x, and that's not d. Okay, so x1 is not d, right? But the second value of x, which will be found by solving this equation, is going to be d when this equals 0. So you got, basically, this is a 0 product property. 2 things multiplied together give you 0. Either one product is 0 or the other. So you have 1.5 minus 0.5 e to the power of 0.02x is equal to 0. So we've got 1.5 is equal to 0.5 times e to the power of 0.02x. You can divide both sides by 0.5. 1.5 divided by 0.5 is like 15 divided by 5, which is 3. 3 equals e to the power of 0.02x. And now we want to find what e is, what x is. So we want to get rid of the exponential function. So what we can do is we can take ln of both sides. So if you take ln of this side, you got ln 3. If you take ln of that side, you'll end up with ln of e to the power of 0.02x. The power law will bring the 0.02x down, and the ln e will become 1. So you're left with 0.02x. So x, therefore, is going to be 1 over 0.02. Now, 0.02 is what? 0.02 is 1 over 50, right? So let's just write that as, that's 1 over 50, because that's 2 over 100, so it's 1 over 50. So that's x is going to be 50 times ln 3. Okay, because that's 1 over 50. Get rid of that, multiply by 50, you got 50 times ln 3. But they want the answer to 2 decimal places, okay? And we can, so that's x. So this x2, this is x2, and we can say x2 is d. So d is equal to 50 times ln 3. Yeah, 50 times ln of 3, and that gives you 54.9306, 54.9306, 2 decimal places. So D is equal to 54.93 meters. Okay, so there's the answer to part A. Okay, so D meters. Well, D is in meters, so we don't have to write that down. Okay, we can just write 54.93 because it says D is in meters, so that's fine. Leave it like that. Okay, now the next part of the question, it says part B. Now part A is, I guess, and part B I can kind of lump them together. This is just basically about functions, I guess. Part B is more to do with differentiation. It says show that the maximum value of h occurs when x equals 50 times ln of 150 over x plus 50. Right? So we got to find the maximum value of h. Now, if you think about the maximum value of h, that's going to be, okay, up here, where there's a turning point, the stationary point. And that's the key. The stationary point, at the stationary point, the gradient of this graph is 0. What is the gradient of this graph? It's h against x. So this is where dh dx is equal to 0. Okay, the gradient of the graph of this graph is given by dh dx, and we've got to find where dh dx is equal to 0. So we know that the maximum, okay, I'll write it like this. H max is when dh dx is equal to 0. All right. So what we're going to do is we're going to find dh dx. So we're going to take h and we're going to differentiate it. So how do you find dh dx? Okay, well, the first term is just 1.5x. When you differentiate that, that becomes 1.5, which is like 3 over 2. Okay, that's like 3 over 2. What I'm going to do, is I'll just rewrite these as h equals, I prefer to use fractions and decimals, minus a half x e to the power of, I'll leave this as a decimal, no problem. Okay, now, so dh dx equals 3 over 2, and then you got minus, and now I have a half times, and I've got here a product of these two functions. I can include the half with the x, I can keep it outside, no problem, I'm keeping it outside, and the answer I get for this I'll multiply by a half. So here I have a product of two separate functions. Okay, it's not a function within a function, it's the product of two separate functions, so I have to use the product rule. Okay, to use the product rule, I'm going to call one of the products u, and the other one v. So one of them is x, I'm taking this as separate, and the other one is e to the power of 0.02x. Okay, so differentiating x gives you 1, differentiating e to the power of 0.02x, well, this you're going to use a chain rule. So it stays the same basically, but then you multiply by 0.02. That's 0.02 times e to the power of 0.02x. And the product rule is you multiply these together, that gives you e to the power of 0.02x, and then plus these two multiplied together, so plus, that will be 0.02 times x times e to the power of 0.02x. Okay, now remember this is like 1 over 50. This is 2 over 100, which is 1 over 50. These I'll write them as fractions because I think that will make life a bit easier. Okay, so that's going to be 1 over 50. And that's dh dx, so I have to make this equal to 0. So I've got 3 over 2 minus a half times e to the power of 0.02x minus, that's going to be 1 over 100. 1 over 100 times x times e to the power of 0.02x, and that's equal to 0. And remember, we have to end up with something that looks like this. So we have to make these x's the subject. So the first thing I can do is I can keep the 3 over 2 on this side, and I can add these both to both sides to make them positive, and just so that I separate these terms with the x's in it. So I have e to the power of 0.02x times a half plus 1 over 100 e to the power of 0.02x. Now what I'm going to do is here, just to get rid of the fractions, I'll multiply both sides by 100. Okay, so if I multiply both sides by 100, 3 over 2 times 100 is going to be 3 times 50, which is 150, which looks promising there. And 1 over 2 times 100, of course, is 50. So I have 50 times e to the power of 0.02x. And 1 over 100 times 100, of course, cancels out. So I'm left with e to the power of 0.02x. All right, now I want to make this x a subject. That's what's happened here, of course. That's what got a lin there. So how do I make the x a subject? There's something missing here, sorry. There's something missing here. The x went missing. Let me just be very careful about this. Easy to make silly mistakes. The x from here, it went missing. See? That's where you have to be very careful not to make these mistakes. 0.02x, it's a good thing that I noticed it. So this is, as I said, going to be x times e to the power of 0.02x. So we have an x here, and we have an x in there. Of course, it's the x's in the power of e that has been made the subject. That's why we ended up with ln. Okay. So what we're going to do now is we are going to take out e to the power of 0.02x as a common factor of these two terms. So I got 150 equals e to the power of 0.02x. And here I'm going to have 50 plus, and I'll have x here. And then I can divide both sides by 50 plus x. So I've got 150 divided by 50 plus x equals e to the power of 0.02x. And now we want to end up with this, remember. So this x has been made the subject. Now I'm ready to take ln of both sides. If I take ln of both sides, this becomes the ln of 150 over 50 plus x, and this becomes 0.02x, sorry. Take ln of this side, 0.02x. Okay, and we know 0.02 is 1 over 50. Okay, so we know that this is 1 over 50 here. Okay, so this can be written as 1 over 50x. And this side we have ln of 150 over 50 plus x. Multiplying both sides by 50, we end up with x equals 50 times the ln of 150 over 50 plus x. And there we have our answer as required. Okay, so this is to do with differentiation, and it's kind of getting us ready for iteration. I was going to save this video in like two separate videos, but I think I'll just save it in one video to do with iteration, and I'll put a bit to do with differentiation in there as well. So that's basically, this is called the iterative formula. Okay, whenever you have a formula where you have a letter in terms of the same letter, okay, this is called an iterative formula, and it will help us to basically solving this, choosing values of x which are close to the turning point will help us to find the value of the turning point, in a accurate manner. Now for part C, okay, it says, as I mentioned, it's to do with iteration. This, what we just derived there, is called the iterative formula. The iterative formula, xn plus 1 is equal to 50 times ln of 150 over xn plus 50, with x1 equals 30. So we want to use the iterative formula, first of all, to find the value of x2. So x2 basically is when you take x1, which they gave us. Okay, they gave us x1 is 30, and you use it in the iterative formula. So x2 is going to be 50 times the ln of 150 over x1 plus 50, which is 50 times the ln of 150 over 30 plus 50. And that will give you the answer for part 1. Okay, so we can use the calculator for that. And we can just basically put this in here. So we have 50 times the ln, oops, there's already a bracket there, of 150. Okay, now actually what I'm going to do is this, before I go on, because part 2 says find by repeated iteration. the horizontal distance traveled by the golf ball before it reaches its maximum height. Okay, so basically, when I find what x is here, that is the horizontal distance traveled by the golf ball when it reaches its maximum height, because this is the value of x where we're going to have a maximum. So by using the iterative formula, we are answering this question. But part one only wants the first iteration. We want to find the iteration that settles down to give you a fixed or a settled value. So I'm going to set this iterative formula up in a special way so that you don't have to keep typing these values in. And the way to do that is to take the initial value of x, which is 30 in this case, and press equals. And then I'm going to set up this equation. I'm going to set up this iterative formula in the calculator. So I'll say 50 times the ln, and I have my fraction. I'll have 150 over. Now, instead of putting 30, I'm going to put answer, because I pressed 30, then I pressed equals. That means the answer in the system of the calculator right now is 30. And I'm going to put plus 50, and I'm going to close the bracket. So when I press this, as the answer in the calculator right now is x1, this will give me x2. Press equals, it will give me x2, which is 31.4304. So that's 31.4304. Now they want this to 2 decimal places. So that's 31.43. Okay. Now we can find x3. Now we don't have to keep writing these steps down. We can just now do the following. Okay. I'm just going to press equals again. Why? How will that find x3? Well, now the answer in the system is this. So what we got to do to find x3 is we got to put x2 in here. Okay, and this is x2. And this is going to go in there because it's the last answer. So I press equals now, it's going to give me x3. So that 30.5443. So 30.5443. I don't have to round these until I get to the one which settles down. So x4 equals, it's a good idea to write them down. Press equals again, gives me 31.0913. 31.0913 goes on. Okay, that's not rounded there. I just put dot, dot, dot. And then the next one, press equals again. See, now every time it puts a new value in there, this is now going to be x5. That gives you 30.7529. 30.7529. It hasn't really settled down yet, so let's carry on until it settles down. Equals again, 30.962. It seems to have to be settling down a bit. So 30.9620. 30.9620. Let's do x7. Okay, x7. Press equals again. It keeps putting the last value in. That's 30.8327. 30.8327. And x8. 30.9126. 30.9126. Still hasn't really settled down properly. It's 30 point something. 30.8, 30.9. Let's see. We want 2 decimal places at the end. So equals again. 30.8632. 30.8632. What it's doing is homing in on the final answer. So x10 is going to be 30.8937. 30.8937. And then x11, let's keep going. 30.8749. Okay, so 30.8, was it again? 8749. That's the answer for the other question, by the way. All right, and then x12. X12. 30.8865. 30.8865. Just keep going a long time here. 30.8793. 30.8793. Okay, so it's like 8788. Let's see which one will become. Keep going. 30.8838. I thought we got there by now. 8838. Okay, so it's definitely 30.8 something. But what's it going to be? Let's carry on. Do we get there? So press equals again. 30.8810. So it's x15. The pen gone. So okay, so x15. I think it's going to get there soon, so I'll just write them down here. So that's 30.8810. 30.8810. Let's see if it's going to be 30.88. Let's carry on. 30.8827. 16. 30.8827. Keep going. 30.8817. X17. 30.8817. And X18. 30.8823. 30.8823. It's going to be 30.88, it looks like, if you round it to two decimal places. Let's do X19. 30.8819. Yeah, it's going to settle to 30.88. Okay, so I can stop there, and I can see that if you carry on, it's going to basically stop there. So it's 30.88, quite obviously. So therefore, we can say the distance traveled before it reaches maximum height is going to be 30.88 meters. So the distance traveled is 30.88 meters. Now here you should put meters because they're asking you for the distance traveled. It's not asking you for like what's x equal to, right? And you know, x is defined as the distance it moves, for example. Like in the first question, in part A, it says find the value of d, right? To two decimal places. And d is defined as d meters. So you don't have to put meters here. But in the last question, it says find the distance it's traveled, okay, before it reaches its maximum height. Okay, so you should put meters here because that is not defined as something, you know, with a unit. So you should put 30.88 meters. Okay, that's something that's mentioned in the mark scheme. You'll be careful about that. So if they're telling you to find a value of a letter which they've defined with a unit, you just have to put the value of that letter. If they tell you to find something like a distance traveled, and you know the thing is not a letter that they gave you to find, which is already defined with a unit, you should write the unit down. All right, so there's the answer to part C, and that concludes question number 8 from this paper. Other questions from this particular paper can be found in the playlist on the top right of the screen at the end of this video. Now, this question had a few different things. One of them was differentiation, which I'll put over here. The other one was exponential modeling. I'll put something to do with that over here. And the other one was iteration and numerical methods, which I'll put over here. Thank you for watching. I hope that was clear, and see you soon.